Alright, let's answer the quiz questions. Last quiz, quiz number 5, which is about the chapter 2, Rotational Dynamics and Equilibrium. The first question is about the center of mass. The question is saying that if a hammer is thrown into air, the ends of the hammer trace out a circular path, B circles around its central mass, C elliptic by around its central mass, and the parabol around its central mass. The answer of this question is circles around its central mass. But when students are answering this question, they confuse, they mix that parabolic path and a circular path. So when we throw a hammer into air or any object into air, the object's central mass of the object will follow a parabolic path, but ends of the hammer will make circular path. For example, this is the end. This end will draw a circular path around the center of mass. This is the answer B. Question number 2. 2 kilogram bicycle wheel with a radius of 0.3 meter turns at a constant angular speed of 12 radians per second when a 0.3 kilogram reflector is at a distance of 0.18 meter from the axle. What is the angular speed of the wheel when the reflector slides to a distance of 0.24 meter from the axle? So initially this reflector is at 0.18 meter from the axle, but then slides to a farther distance, which is 0.24 meter from the axle. So which means the distribution of mass is gets farther from the axis of rotation. That's why moment of inertia must increase and then angular speed must decrease. But system has two components. One of them is the bicycle wheel, so its shape is not changing, and bicycle wheel has a moment inertia mr squared. But second one is the reflector. The reflector draws a circular path as the bicycle will rotate. That's why its moment inertia also mr squared. However, according to conservation of the angular momentum, initial moment inertia multiplied by initial angular speed must be equal final moment inertia of the system multiplied by final angular speed. Because system has two components, one of them is the bicycle wheel. It has a moment inertia capital mr squared. This doesn't change. And the reflector, initially it's at the initial initial distance to the axle, which is mr I squared, multiplied by initial angular speed will be equal. Because moment inertia, final moment inertia of the bicycle wheel is not changing, because shape is not changing, it's again mr squared, but reflector is moving to a new distance from the axle, which is 0.24 meter. So that's why I'm going to write his final multiplied by final angular speed. So bicycle wheel itself has 2 kilogram. So its radius of the bicycle wheel is given as 0.3, which is 0.3 squared, plus mass of the reflector is 0.3, so 0.3 multiplied by initial radius of the bicycle, the reflector is 0.18, which is 0.18 squared, times initial angular speed, which is equal, given as 12 radians per second, must be equal. So again, you are going to continue writing the second part of final part of the final angular momentum. Final moment inertia, because bicycle wheel's shape is not changing, it's again 2 is the mass, and the radius of the bicycle is 0.3 squared, plus the reflector is now moving to a farther distance, which is 0.24. This is the radius of the reflector, so mass of the reflector is 0.3, but radius will be 0.24 squared multiplied by final angular speed. So by this equation, so you are going to calculate this part and that part, and after that it is not so hard to calculate the omega final. So answer, as I remember, was 11.5, and you do calculation, you can calculate the answer. So question number 3, when an ice skater brings his hands closer to his body, which of the following will increase for ice skater? So when the ice skater bring hands closer, so mass gets closer to axis of rotation. If distribution of mass gets closer to axis of rotation, so then moment inertia must decrease. Moment of inertia decrease, that's why we are going to cancel this, because it says increases. Moment inertia never increases. If you take the masses away from the axis of rotation, moment inertia decreases. But this question says hands are brought closer to the body. That's why distribution of mass gets closer to x rotation. That's why inertia decreases. But according to conservation angular momentum, L is equal to I times omega. If moment inertia decreases, so angular speed must increase to keep the angular momentum constant. So that's why angular speed must increase. What is increasing? So angular speed is increasing. This is the answer. Mass doesn't change, it's the amount of the matter. There is no change in the amount of matter. Angular momentum also doesn't increase or decrease because it's ice skater on the ice. We almost friction is zero. That's why no torque is produced. Only torque can change the angular momentum because there is no torque on the ice skater's body, acting on the ice skater's body. That's why angular momentum must stay constant. It never increases or decreases. Next question is, a solid ball with a mass of 2 kg and the radius of 0.1 meter start from rest at a height of 5 meter. It is the H. Rolls down 30 degrees slope. What is the instantaneous linear speed of the central mass when it leaves the incline? So you can calculate the Heck equation. Remember, if an rigid object is released from some height on an incline, so then we can calculate the speed of that object at the bottom by the equation, which is B is equal to square root of 2gh divided by c plus 1. And remember, c is the coefficient of inertia. Because it's a solid ball, it is 2 over 5. You are going to write every given here in the question. 2 times 9.81 times h is given as 5 meter multiplied by 5 divided by c plus 1. C is 2 over 5 and then plus 1. Don't forget to get into bracket when you are making calculation. So you will get the answer in this question. Calculator, use of the calculator is important here. So you can calculate this by just one step, like this square root of 1 bracket, which is equal to 2 times 9.81 times 5 divided by once again bracket, because denominator always must be in bracket. 2 divided by 5 plus 1, close the bracket, once again close the bracket. So you will get the answer as 8.38 or 8.4 almost. So this is the answer of the question. So next question is about equilibrium. It says that a man of weight 720 newtons stands on a light board of length 2 meter. So you are going to first draw a light board of length 2 meter. I am drawing it. So this is a board which is 2 meter long. And indicate the distance. That distance is 2 meter long. Light board means you can assume it's neglect the weight of this board. That's why you are not going to draw its weight. If the force is exerted by the first support, it's fixed on two supports at its extremities. Extremities means one here, another one is here. You are going to locate here are two supports. One support is here, another one is here. So you are going to give name because question says first support and second support. So one of them you are going to write first support, another one you are going to say second support. It doesn't change. Here is 1 or 2 or 1 or 2, no difference. If the force exerted by the first support, because each support is applying an upward force, because Fn1 for the first support, Fn2 for the second support, and it says that the first support applies a force 540 Newton. So what is the distance between the point where the man stands and the first support? So you are going to locate the man somewhere here, and this man has a weight which is 720. Of course, this downwards, and question is asking what is this distance between them where the man stands and the first support. That x you are going to calculate. So x rotation is the location of the unknown force. Remember we said that like this. So this is the location of the just one unknown force here. It is here. According to this point, you are going to define the torque. This produces a clockwise torque, so negative Fn. 1 produces a positive torque in the clockwise, counterclockwise positive torque. After that, you are going to calculate the torque one by one. Torque of 720 is negative 720 multiplied by distance from force to x of rotation. It's not defined, that's why we should define that. That distance is equal to 2 meter is the total length. So that is, we set this part is, that must be 2 minus x. 2 minus x is the distance from 720 divided by, to the x of rotation. 2 minus x. This is the torque produced by that force, 720. Another force is 540, which is the force applied by the first support. So it's positive. 540 is the force. The distance from force to the x of rotation is 2 meters. So you are going to multiply this by 2 meters, which is equal to 1080 Newton that meter. This is the second torque. So when you add these two torques, because the system is in equilibrium, you should get it must be 0, and 1080 minus 722 minus x will be equal to 0. When you continue this way, you will get the x as from here, which is almost equal to 0.5 meter. So this x is the distance between where man stands and the the first support. That's why it's asked the distance between the point where man stands and the first support. So x is that distance. We are going to circle 0.5. Question number 6 is asking about a student holds a 3 kilogram mass at each end and while sitting on a rotating stool. So when his arms are extended horizontally, the masses are 1 meter from the axis of rotation. So initially the masses are at 1 meter from the axis of rotation. Then it says that if the student pulls the masses horizontally to 0.3 meter, so that's why radius gets smaller. Initial reduces 1 meter, final reduces 0.3 meter, which means distribution of mass gets closer to axis of rotation. If distribution of mass gets closer to axis of rotation, the moment inertia must decreases. So then angular speed, if moment inertia decreases, so then because angular speed and moment inertia are inversely proportional, angular speed must increases. So this is the answer. Angular momentum increases. As I said, angular momentum can only increase if there is a torque produced on a system or on an object. But in this question, there is nothing talked about the torque. So that's why we cannot say angular momentum increases or decreases. Moment inertia increases, no opposite. Moment inertia decreases because mass are brought closer to 0.3 meter from 1 meter. That's why it's getting closer to axis of rotation. Mass increases. Mass is the amount of matter, so it does not change. So angular speed increases, the correct answer. Next question. Bicycle tire rotates, starts rotating from rest, which means initial speed is 0. A net torque of 6.75 Newton is required to increase the angular speed of the tire to 100 radian per second in 2 seconds. So initial angular speed is 0. But final is omega final is equal to 100 radian per second, and time interval for this increase delta t is given as 2 seconds. Calculate moment inertia of the tire, it's asking. And most probably we are going to use torque is equal to I times alpha equation, because torque is given, and we will, because this is given, I is question, alpha must be first calculated. It's easy to calculate alpha because alpha is omega final minus omega initial divided by delta t. So omega final is 100 minus omega initial is 0 divided by 2, which is equal to 50 radian per second squared. This is alpha. Then you can write this alpha right here, and then torque, which is 6.75 right here. 6.75 is equal to I times alpha is 50. So when you divide both sides by 50 and 50, you will get the answer as I remember it was 217 or something like this. Let me calculate. I'm not sure about that. So which is 6.75 divided by 50, which is 0.135. Yes, 0.135 is the answer of this question, kilogram meter square, which is the moment inertia. Next, calculate rotational kinetic energy of 150 kilogram football of the reduced 10 cm rotating at fitting about center of mass. You remember equation for rotational kinetic energy rotation is 1/2 I omega squared, and the 1/2 I is given in the question as 2/3 mr squared. Omega is also given, so you are going to write everything here because these two will simplify. You can 1/3 mass of the ball is given as 150, which is 0.15 kilogram. Radius is given as 10 centimeter, 0.1 squared, times angular speed is given 16 square root of 16. When you multiply them all, you can get the answer as 0.15 multiplied by 0.15 multiplied by 0.1 squared multiplied by 16 squared, which is equal to this, divided by 3 is the answer, which is 0.128. 0.128 joule is the answer, which is D. So geometric center of mass of a bowling ball is geometric center of the sphere. If the bowling ball is a perfect sphere, if there are no finger holes, remember the bowling ball is not perfect. Yeah, it's shaped as a perfect sphere, but some part of bowling ball there are 4 finger holes, and you are going to put your finger and then you are going to rotate the ball. That's why you cannot say that this side and that side equal in masses. For that reason, central mass must move towards the heavier side. This side is heavier. The side which is the part which has the finger holes will be less in mass. That's why the central mass must be away from the finger holes, so then which must be close to center of mass, yes, geometric center of the sphere, but away from the finger holes, because of the heavier side is this side, lighter side is that side. That's why central must be a little away from the finger holes. And another question number 10, it says that a solid ball and a solid disc, and then the ring starts at a height of 3 meters and rolls down 20 degrees slope at the same time. Both ring and disc have the same mass and radius as the ball, and all have the same mass, all have the same radius. Which other two objects will arrive at the bottom last? It's asking last, final, if all roll without slipping. Solid ball has a moment inertia 2 over 5 mr squared, solid disc has a 1 over 2 mr squared, and ring is 1 mr squared. So remember, if they roll along on an incline, the one which has a smaller moment coefficient of smaller moment inertia will move faster. The solid ball will move fastest, and solid is faster, ring will be slowest. That's why last one will be the ring here. So is a measure of object's resistance to a change in rotational motion about some axis. This is the definition of moment of inertia. It is the measure of object's resistance to a change in rotational motion about some axis. Next question number 12. A bicycle tire of radius 0.3 and mass of 1.5 starts rotating from rest and attains 12 rating per second in 6 seconds. Calculate net torque on the tire. This time again torque is asked, which is called I times alpha. Because it's a bicycle tire and its moment inertia is given in mr squared, you are going to write here 1.5 kilogram times I is equal to mr squared. Let's write first the equation, mr squared. Alpha, because alpha is not given, it must be calculated. Final speed minus initial angular speed divided by delta t. This is the alpha. And you write everything here and then multiply them. You will get the answer. 1.5 times r is given as 0.3 watt squared, multiplied by omega final is 12, omega initial, because it's from rest is 0, divided by time interval 6. So when you multiply them, and you will get the answer. The multiplication will be, let's multiply them all. 1.5 times 0.3 squared multiplied by 12 over 6 is 2. When we multiply them all, it's 0.27 is the answer, which is the A. How would the force required to open a door change if you put the handle 1/4 of the initial distance to the axis of rotation? So then remember, to open something and to close something, to rotate something, we need a minimum number of torque, which is known as required torque. And the force is initially at the end of the door, so then distance is D. So the force required torque is to open this door or close this object is F times T, which is the torque. But if in the second case, you are going to take this force to 1/4 and divide it into 2, this is the 1/4. Somewhere here you are going to take the force. That distance to the axis of rotation will be D over 4. But to produce the same amount of torque, because the required torque must be constant. So if you get to again F times T, because D decreased by 2, F must increase by, because D decreased by 4, F must increase by 4, then D over 4 times 4F. So this 2, 4 will cancel, simplify. That's why F times T required torque again will be obtained. That's why it must increase, the force must increase by 4 or change by a factor of 4. Question number 14. A solid vertical cylinder of mass of 2 kg and radius of 0.25 meter rotates with an angular speed of 7 radians per second about fixed vertical axis through its center. Calculate angular momentum. Angular momentum is I times omega, remember. Because it's a disk has an angular momentum 1 over 2 mr, angular moment inertia 1 over 2 mr squared. It's given in the question. Omega is also given. You are going to write everything here and then you will calculate it. 1 over 2 m is given as 2 kilogram. R is given as 0.25 but squared. The angular speed is given as 7. So then multiply them all, you will get the answer as I remember it was 0.44. Let's calculate again. 0.25 squared times 7, which is equal to 0.44. Yes, 0.44 is the answer. Two children are balanced in a uniform seesaw which is supported in the middle of a pivot. So there's a seesaw. Let me draw a seesaw. And two children are supported. In the middle point somewhere here is a pivot point. One child is 200 Newton and 1.2 meter from the pivot. So then locate one child somewhere here. 200 Newton and distance from this child to the pivot point is 1.2 meter. The second child is 160 meter. Where the second child must be seated? Of course, it must be on the right side, somewhere here, 160 Newton. So distance to this child is the question. Here is F and this 4. Here is the axis of rotation. So then you will find what X is. So this produces a counterclockwise force. That force produces a clockwise torque. And then you will calculate torque one by one. 200 times 1.2 is the torque produced by 200 Newton. So if you multiply that, it becomes 240 Newton dot meter. But other force also produces torque. What is negative? Negative 160 times X. So sum of these two torque will be equal to 0. 240 minus 160X is equal to 0. X is equal to 240 divided by 160. If you divide them, you will get the answer 240 divided by 160, which is 1.5. So then the second child, which this 160 Newton child, must sit at a distance of 1.5 meter from the pivot point or axis of rotation. Question number 16, it's asking which of the following represents Newton's second law for rotation. Remember, Newton's second law for circular motion was F times m times a. Fc times ac is the Newton's second law for circular motion, or any Newton's second law for linear motion. For rotational motion, the rotational analog of force is torque. Rotational analog of mass is moment of inertia. Rotational analog of linear acceleration is angular acceleration. So that's why torque is equal to I times alpha is the Newton's second law for rotational motion only. Instead of alpha in the question, it is written delta V over delta T. So this is the Newton's second law for rotational motion. Identify in which the following situations the condition of rotational equilibrium is applied. Yes, so there will be a rotational equilibrium, but no translational equilibrium. The answer is here football traveling through the air, because when you throw a football up in the sky or through the air, so then this ball always experience an acceleration, free fall acceleration, which is a linear acceleration. So if there is a linear acceleration, there will be no translational equilibrium. But when you throw up the ball in the air, because every point on the ball experience the same force, so then these two forces, the torque produced by all these forces will be equal to 0. Net torque acting on the ball will be equal to 0. So rotational equilibrium is applied, but translational equilibrium is not applied. Question number 18. A tin hoop rolls along a horizontal smooth surface at constant linear speed without slipping. The ratio between its rotational kinetic energy about the center of sphere to its total energy is equal to what? Remember, the equation for such questions are like this. There was a hack equation we were using. Kinetic energy total divided by kinetic energy rotational is equal to 1 plus 1 over c. C, remember, it was the coefficient of moment inertia, which is here 1. So we are going to write 1 plus 1 over 1, so which is 1 plus 1, because 1 over 1 is 1, so 2. However, question is not this. Question is calculate rotational kinetic energy divided by total kinetic energy. It's just you are going to inverted, rotational kinetic energy over kinetic energy total will be equal to 1 over 2. If this is 2, so then reverse must be 1 over 2. Question number 19. A bicycle designer recently modified a bicycle wheel by adding cylindrical weights, yani masses. Masses are added to the spokes of a bicycle wheel. So remember, there are spokes. These are called spokes. You are going to add masses here. When mass is added to any object, it's not bicycle. If you add mass to any shape, so because mass increases, moment inertia is proportional to mass. Moment inertia in all cases will get greater. So the moment inertia gets greater, will rotates not easier, harder. Total mass gets smaller. It's impossible because you are adding mass, so it gets greater. Two forces acting on a table are equal in magnitude, opposite in direction, and along the different lines. So then here is I'm going to draw a table. So this is a table. There will be two lines, two different lines. One force will act in that direction. The other force will act like that. They are opposite in direction, equal magnitude, like 10 Newton and 10 Newton, for example. Some of this force acting on the table will be equal to 0 because net force is equal to 0 because one of them is positive 10, the other one is negative 10. So some of them is 0. The net force acting on the table is equal to 0 is the answer. Table, but rotational equilibrium, this produces a counterclockwise torque, that produces a counterclockwise torque because both torques are in the same direction. So this table will start rotating about a point. So there is no rotational equilibrium, but there is translational equilibrium. If no rotational equilibrium, no complete equilibrium. Net torque in object is not 0, so then the table is neither in translation equilibrium nor in rotation equilibrium. It's in translation equilibrium. We said about net force acting on the table is 0. So this is the solution of all problems in the quiz number 5.